Particle of mass 0.5 kilograms is moving under the action of a single force, F newtons, where F equals 4t minus 3I plus 3t squared minus 5t j. The velocity of the particle at time t seconds is v meters a second. When t equals 0, v equals 8I minus 7j. We want to find an expression for v in terms of t. Okay, part A, we're going to use Newton's second law, F equals ma, in order to link this force to the acceleration, and then what I can do is I can integrate that acceleration in order to get an expression for v. So the force is 4t minus 3I plus 3t squared minus 5t j equal to 0.5a. If I double both sides of the equation, I'll write it as a equals, so I get 8t minus 6I plus 6t squared minus 10t j. At this point now I've got an expression for the acceleration. I can integrate this, so I'm writing a velocity equals the integral of 8t minus 6I plus 6t squared minus 10t j, all integrated with respect to t. So when I work through this, my velocity, t integrated goes to t squared, divide the 8 by 2, we get 4. Integrate the 6, and I get 6t. And that's my I component done. Plus, raise the power of the t to the cubed, and divide 6 by 3, we get 2. Minus, raise the power of the t to squared, divide the 10 by 2, and I get 5. And that's my j component done. Don't forget there is a constant of integration which will be a vector, and we shall find that in a moment. Now, what we're told in the question is that when t equals 0, v equals 8I minus 7j. So substituting this in, v, which is 8I minus 7j, equals, substituting t into the I component will just give us 0 for I. Substituting t equals 0 into j component will give us j equals 0. And so I just get left that the constant is 8I minus 7j. So finally, the equation can be written as 4t squared minus 6t plus the 8I from the c, so plus 8I, plus 2t cubed minus 5t squared, and then minus the 7 from the c component, j. And this is the velocity of our particle with respect to time. How are marks awarded in this question? Well, first of all, you get a method mark. If you have used Newton's second law to set up this equation, you then get an accuracy mark if you got the equation a equals in this form. We then get a method mark for demonstrating that we are going to integrate to get the velocity. There is an accuracy or an answer mark for getting the correct result of integration. And then finally, there is an accuracy mark for identifying the constant of integration using t equals 0 and v equals 8I minus 7j. Okay then, so let's look at part B. Part B says when t equals 3, the particle receives an impulse of 2I minus 9j Newton seconds. So find the speed of the particle immediately after the impulse. Okay, so what we're told here is that j equals 2I minus 9j Newton seconds. What we're going to use, because it's not linked to time applied for a force or anything, is we're going to use that the impulse is the mass times the velocity minus the mass times the initial velocity. So the impulse happens when t equals 3. What I want to do is I want to find then what is the initial velocity at t equals 3. What is the velocity before it changes? We're going to use the answer to part A, that v equals 4t squared. Let's put 3 in straight away. So 4 lots of 3 squared minus 6 lots of 3 plus 8i. And then we're going to calculate the j component, which is 2 lots of 3 cubed minus 5 lots of 3 squared minus 7j. So the initial velocity, well, the velocity at time equals 3, will be given by, we have 4 times 9, which is 36, take away the 18, which is 18, plus 8, which is 26i. We then have 2 lots of 27, which is 54, minus 5 lots of 9, which is 45, so I've got 9 from those first two terms, minus the 7 leaves me plus 2j. So time equals 3, time equals 3, velocity is 26i minus 2j. Now the important thing to remember here is actually this will be equal to u, because this is going to be the starting velocity. So now my impulse, we're going to say u equals 26i plus 2j. In this scenario, we're going to get j equals mv minus mu will lead to 2i minus 9j equal to 0.5 times 26i plus 2j plus, sorry, that's the wrong way around, so let's just 0.5v here, my apologies, and then minus the 0.5 times the 26i plus 2j. Doubling the equation, I get 4i minus 18j equals v minus 26i minus 2j. So let's add the 26i and the 2j to both sides, so that what we get left with is v equals 30i minus 16j. Now, at this point we need to be really careful, because the question asks for the speed of the particle. At the moment I've got the velocity. The speed is equal to the magnitude of the velocity. So I'm looking at the square root of 30 squared plus minus 16 squared, and when we work through this you get an answer of 34 meters a second. Okay, let's have a look at how the marks are awarded in this question. So we get a method mark for correctly identifying, standalone mark for calculating the velocity at time equals 3 as 26i plus 2j. There's a method mark if we attempt to use the impulse is mv minus mu, that change in momentum. There is then a correct answer mark if you have worked down to find that the velocity is 30i minus 16j. Finally, remembering that the speed is the magnitude of that velocity, you get a method mark for doing the modulus of that vector, and you get an answer mark for the correct answer only again if you've got 34 meters a second. I hope that all made sense and you understood that question.